Math 2, Unit 5, Lesson 6. Today we're talking about trapezoids and kites. You'll want to have out your yellow card and a highlighter and pens. So if you don't have that, go ahead and get that out and turn to page 306. So on page 306, we are starting to talk about isosceles trapezoids. And it tells you that if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. And so if you look here, you can see that angle T and P are congruent, and those are base angles. And on top, angles R and A, those are also congruent, and those are also base angles. Okay. Go ahead and turn to page 307. And on page 307 here, it states that in this diagram, it's an isosceles trapezoid and measure angle R is 106 degrees. What is measure angle P? So I'm just going to write over here measure angle P, measure angle Q, and measure angle S. And what do those equal? Well, based on our definition for an isosceles trapezoid, one of those should be very easy to find. And that should be angle S. And because if it's an isosceles trapezoid, then the base angles, and this would be one base, those are congruent. And so that means that angle S here is 106 degrees. In a quadrilateral, we can find out how many degrees are inside, and this might be one that you guys should have memorized by now, but in case it isn't, the degrees inside is n minus 2 times 180. So that would be 4 minus 2 times 180, and 2 times 180 is 360 degrees. And so if the whole trapezoid has 360 degrees, and we know that two angles are 106, we can subtract that and then separate them, divide them between those two angles. So that would be one way of doing it. The other way of doing it is that, well, let's just do it that way. So 106 plus 106, and if we add down there, we end up getting 212. So if I take 360 minus 212, I'm going to have to borrow, and I get 148 left over. Now, one of these isn't 148. Both of them together are 148. So in order to separate them, I would need to do what? So hopefully you said divide by 2. So 148 divided by 2 is 74. So that means that measure angle P and also Q are 74 degrees. Okay, another shortcut is that since these are both parallel lines, these are transversals, and so we know that these two sides, because they're consecutive angles, should also equal 180 degrees. So in order to find Q there, I could have just taken 180 minus 106 and got 74 as well. Okay, on B now, it says that in problem 1, if C, D, E, F were not isosceles trapezoids, would C and D still be supplementary? And so the answer to that is yes. Okay, and the reason is that DE is parallel to CF. And so again, we'd be dealing with same side interior angles are congruent. And so in this case, this C angle would be 65, or C and F are 65. And then how much would angles D and E be? And so I think it's much shorter to do those as consecutive angles, and our interior angles are congruent. And so if we go 180 minus 65 here, we would have to borrow, and we end up getting 115 degrees for both of these angles. And actually, this was not supposed to be same side interior angles are congruent. Some side interior angles are supplementary. but our base angles are congruent. Okay, so practice here. I believe we're still on page 307. I'd like you to find the missing measures. So I like to go over here and just write measure angle 1, measure angle 2, and measure angle 3. So finding the congruent base angle is usually the easiest, so measure which one is also 77 degrees. Okay, so hopefully you put measure angle 1 is also 77. And then in order to find 3, I can just know that those add to be 180. And so if I go 180 minus 77, we borrow and we end up getting 103 degrees. So measure angle 2 and also measure angle 3 are 103 degrees. Okay, same thing on number 2. So if you can find those. The easiest one there to find, hopefully, is measure angle 1, which is 49. And then in order to find measure angle 2, again, I can just go 180 minus 49. And we end up getting 131. And if measure angle 2 is 131, then measure angle 3 is also 131. Okay, so let's go ahead and move on to page 308. We have a couple more problems here. So again, we're finding measure angle 1, measure angle 2, and measure angle 3. If you want to pause the video for a minute, you would press enter and give everyone a chance to find the answers on their own, or you can just keep playing it. So measure angle 1 is the other base angle that matches here, and so that would also be 105 degrees. In order to find measure angle 2 and 3, we would go 180 minus 105, which is 75. So measure angle 2 and 3 are both 75. Okay, same thing on number 4. If you want to pause it by pressing enter and let students try it on their own, or if we just keep going, which base angle matches with measure angle A? So if this is 60, the one that's on that parallel line there, the other base angle is measure angle 3, so that is also 60. Then in order to find 1 and 2, we just go 180 minus 60, and we find that it is 120 degrees. Okay, staying on page 308, 308, we're going to look at theorem 57. And here, again, it's talking about the isosceles trapezoid. But if it's an isosceles trapezoid, then the diagonals are congruent. Again, we remember that congruent means equal. And so that just means that line AC and segment BD, those are congruent to each other. Okay, still on page 309. And actually, if you wanted to look at your yellow card as well, we have this definition at the bottom here. So I kind of wanted you to look at this. But this is saying if you take your base 1 and base 2, if you add those two together and divide it by 2, it equals the middle line. Okay? And so that's what it's saying here, but I feel like it's saying it a lot more complex. Okay? And so if we were to take it to this example, which I think is usually the easiest if we're trying to find x, we're going to add the two base angles, so the top and the bottom. So we have 10 plus 8x minus 12 divided by 2 equals our mid-segment, which is 2x plus 11. So again, and I would like circle or highlight the two base angles, so your top and bottom. Since you're taking and you're adding those, you have to divide them by 2. It's like we're getting the average, and the average should equal the mid-segment. I would then at this point, to get rid of this 2, we would multiply by 2 to get rid of the fraction. There's more than one way of doing this, but I think this is the easiest to be consistent on. And so that cancels those 2 out, but we have to multiply 2 on the other side, which means we'd have to distribute it there. And so we'd end up with 10 plus 8x minus 12 equals 2 times 2x is 4x, and 2 times 11 is 22. And then we're just going to solve for x. So here I combine my like terms. I get 8x and negative 2, because 10 and negative 12 is negative 2, equals 4x plus 22. Next, I would subtract 4x to both sides. These cancel. I add 2 to both sides, and I get 4x equals 24. Divide by 4 to both sides, and x equals 6. Now remember that anytime you are solving for x or a variable, you always going to go back and see what the question actually asked. In this case, it says, what is x? And then it also says, what is mn? So in order to find mn, we need to plug x in here. So we'd have 2 times 6 plus 11. 2 times 6 is 12, and 12 plus 11 equals 23. So my answer for segment MN is 23. Okay, so still on page 309, you're going to try example 5. So again, if you want to press enter, or you can just keep playing, but we're going to do the same thing. So we always add the top and the bottom and divide by 2 to equal the middle. So we have 4 plus 7x plus 4 divided by 2 equals 3x plus 5. In order to get rid of that 2 on the bottom, I multiply by 2 to both sides, but remember that you're going to distribute that 2 through there. Here those 2's cancel. We can go ahead and combine our like terms maybe here at the same time. And so I get 7x plus 8 equals, and I distribute and get 6x plus 10. So to finish solving for x, I subtract 6x to both sides. We have x plus 8 equals 10. And then last, I would subtract 8 to get x equals 2. Again, anytime we solve for x, we go back and check the question, and the question actually says find EF. So we're going to plug in 2 for EF, and so we have 3 times 2 plus 5. So I'm using this right here, 3x plus 5, and I'm plugging in my value for x. So I have 6 plus 5, and 6 plus 5 is 11. So 11 is the answer for EF. All right, let's go ahead and move on to page 310. We're going to do one more example like this. And so again, we add our 2 bases and divide by 2. So we add the top and the bottom, divide by 2, and it equals our middle. So x minus 1 plus 15 divided by 2 equals 2x plus 1. In order to get rid of the 2 in the denominator, I multiply by 2 to both sides. But we need to put parentheses so we remember to distribute. These cancel. We have x, and then negative 1 plus 15 makes 14. We distribute through here. We get 4x plus 2. Then to solve, I subtract x to both sides. 14 equals 3x plus 2. I subtract 2. 14 minus 2 is 12. 12 equals 3x, and I divide by 3 to find that x equals 4. This question, I don't have it on there, but they actually wanted us to find EF as well. And so we're going to take 4 and plug it in. So I have 2 times 4 plus 1. 2 times 4 is 8, and 8 plus 1 equals 9. And that is our answer for EF. Okay, moving on, still on page 310, we're going to start looking at kites. So a kite, it says if a quadrilateral is a kite, then its diagonals are perpendicular. And again, we remember that perpendicular means 90-degree angles. So right here, you can see right here at this point, it's making all of those angles 90 degrees. If the diagonals are perpendicular, there's 4 90-degree angles right there. Okay, page 311. So here it's asking us for measures angles 1, 2, and 3. And so I'm going to go ahead and write down measure angle 1, measure angle 2, measure angle 3. So one that looks really easy to me first there would be measure angle 1, because that's in the perpendicular spot, and so we know that 1 is 90 degrees. Okay, so if 1 is 90 degrees and it's saying that this little angle right here is 36 degrees, then we can find this angle right here. Okay, and so we're going to go ahead and do that. Or also, because this is a angle bisector, whatever this angle is right here, 3 is also. So that means measure angle 3 is actually additionally also 36 degrees. And so then it puts us here. So this is 90. We have measure angle 3 is 36. And so again, in order to find measure angle 2, we'd add those together and subtract them from 180, because all triangles are 180. So 90 plus 36. We add down, I get 126, and then to find that missing angle, 180 minus 126, and we end up with 54 degrees as measure angle 2. Okay, so still on page 311, let's move on to question number 7. So again, I'm going to find measures angles 1, 2, and 3, so I'm going to write this here to the side. Measure angle 1 should be easy, that is 90. Since this is 45, we know that 3 is also 45. Measure angle 2, if we add 90 plus 45 together, we end up getting 135, and 180 minus 135 gives us another 45 for angle 2. So measure angle 2 is 45. Okay, number 8 is a little bit more complex, but again, we can do this. We're just going to go ahead and write everything out here. So let's go ahead and do measure angle 1. It looks like we go all the way to 10. Measure angle 2, 3, 4, 5, and then we're going to do 6, 7, 8, 9, and 10. Okay, 4 of them are pretty easy there. Right there in the middle, 1, 2, 3, and 4, all of those are 90 degrees because those are perpendicular lines, perpendicular diagonals. Okay. If we know this is 90 and this one is 46, we can find 10 by adding them together. So if we add 90 plus 46 together, we get 136, and 180 minus 136, we end up getting 44. So that means that measure angle 10 is 44 degrees. Also, measure angle 8 is kind of in that same spot right there. That is also 44 degrees. Okay, and you'll look, these are your perpendicular bisectors. It's important to pay attention to where your equal segments are. So 10 and 8 are equal, but the perpendicular bisector here is with this 46 and the 5. So 5 is also 46. Okay? So if we're writing these down, so if I put 8 as 44 here, and this one was 46, you can see that all of those end up adding to equal 90 degrees. Over here, this is a 90-degree angle. If this is 34, we know that 6 is also going to be 34. Okay, and that means that 7, we have to figure out what 7 is going to be. And so 90 plus 34, we add down, we get 124, and then 180 minus 124, we have to borrow, and we end up getting 56. So measure angle 7 is 56 degrees, and that matches up there with number 9 there, and so 9 is also 56 degrees. And so those are all of your answers for number 8. Okay, if you turn to page 312, they kind of have an example of what your yellow card is. And so we have your yellow card as well. So if you want to go ahead and get that out, we are going to mark everything that we don't have yet. So I'm just going to give you a minute here to get that out. Okay, so hopefully everybody has theirs. Okay, so the first one on the quadrilateral, any quadrilateral, what you should have written there is just that it has 4 sides. It's a 4-sided polygon. And that's what we've been looking with all of these on. Okay, moving over to a kite. If you were to look that up, this one is a quadrilateral with 2 pairs of adjacent congruent sides. The second thing is that diagonals are perpendicular. And then it has exactly 1 pair of congruent opposite angles. Okay, and you can look at my sheet up here later if you didn't have enough time. The trapezoid over here is a quadrilateral with exactly 1 pair of parallel sides. I'm going to do my little mark there for parallel sides. The isosceles trapezoid is a trapezoid with congruent legs. Each pair of base angles are congruent, and the diagonals are congruent. Okay, and again, if you need to look at mine later, you can. I'm going to flip this over now. So a trapezoid, there's actually only one X that is marked, and that is that it has exactly 1 pair of opposite parallel sides. Okay, the kite has, where are we at? The kite has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. Its diagonals are perpendicular, and a diagonal forms 2 congruent triangles. So that is what you should have marked for the kite. Okay, so we're just going to do a couple problems here on the lesson check. So on page 312, number 9, okay, there's 3 angles we're looking for. Measure angle 1, measure angle 2, and measure angle 3. Okay, the easiest one there should be measure angle 2, which is 90 degrees. If this is 90 and this is 78, in order to find what 3 is, we'd have to add those together and subtract from 180. So 90 plus 78, we add down, we get 168, and 180 minus 168, you end up getting 12. So measure angle 3 is 12. Measure angle 1, okay, is the same as the 78, and so 1 is 78. Okay, number 10, we're trying to find measure angle 1 and measure angle 2. You will notice here that this is not an isosceles trapezoid. Okay, but we do have two parallel lines with a transversal, which means that these two angles add to be 180. So 180 minus 86, and we borrow, and we end up getting 94 degrees for measure angle 1. Measure angle 2 works the same way, 180 minus 48, and we get 132. Number 11 says, what is the length of the midsegment of a trapezoid with bases of lengths, or bases lengths of 14 and 26? So remember, to find your midsegment, you add the two bases and divide by 2. So we get 40 divided by 2, so the midsegment is 20. All right, and that is where we are going to stop for today, and we'll be passing out the worksheet.